looking at congruent and similar solids. We spent plenty of time talking about congruent and similar polygons or two-dimensional shapes. And now since we're in the three-dimensional unit, let's talk about it with our solids here. Well, if we look, similar solids, very similar, no pun intended, to our similar polygons or our similar two-dimensional shapes. If you remember our similar two-dimensional shapes, I'm just going to write this down here. Remember our similar two-dimensional shapes, or polygons, right? Always had to be angles were congruent and sides were proportional. That basically holds true for our similar solids. The key we're looking for here is sides being proportional, right? So the ratios of the corresponding measures have to be the same. So in this case, if I'm looking at these two cones here, cone 1 and cone 2, all right, so I got height of 1, radius of 1, height of 2, radius of 2. Yeah, if I set up my proportion, I could say height of 1 over the height of 2 has to equal the radius of 1 over the radius of 2, right? The sides have to be proportional, right? The ratios have to be the same for them to be similar. So if I said these two cones were similar, this proportion would hold true right here, right? The corresponding sides, height of the 1 over height of the 2, has to be the radius of the 1 over radius of the 2 since you did the height of the first one first. Okay, and that's things that we've done before, but we're just using them with similar solids now instead of two-dimensional shapes. Well, congruent solids, this is just straightforward. Basically, they have to have the exact same side lengths. So the height of the first pyramid has to equal the height of the second pyramid. Same thing with the length of the first has to equal the length of the second. And it has to work for every single side. Or we could say that the ratio of corresponding sides has to equal 1. So basically, if I put h over 1, h sub 1 over h sub 2, it's got to be 1. Same thing with slant length 1 over slant length 2, it's got to equal 1, right? Well, any number divided by itself is 1. And so if they're the same thing, for example, let's say this was the height 14, this is the height of 14, 14 over 14 is 1, right? So as long as they're all the same, they're congruent. Don't need to spend much time with that. So let's take a look. It says determine whether the pair of solids is similar, congruent, or neither. If the solids are similar, state the scale factor. And remember when we use scale factors, it's basically the ratio of our new image over the old image. Okay? And with the new one, we'll just put which one's second. So if I look here, similar, congruent, or neither. It's easy to look to see if they're congruent first. I just look to see if they're all the same. Well, radius of the circle 6, radius of the circle 6. So I'm looking to see if they're congruent. Well, then down here, height 15, height 16. I know they're not congruent. Okay. I also already know they're not similar without even having to set an upper proportion. Because if I look, 6 and 6 are the same. So that means the height and the height would have to be the same for them to be proportional or congruent. Well, they're not. And if I wanted to set this up, I could say this is cone 1, cone 2. Radius of cone 1 corresponds to the radius of cone 2. Height of cone 1 corresponds to the height of cone 2. Well, they don't equal. I already know that. So it is not similar. So in this case, they would be neither, which means I don't have to worry about a scale factor because there is none. All right. Looking at the pyramids, let's do the same thing here. Well, I already know they're not congruent just by looking at the numbers. None of these numbers are the same. So to test to see if they're similar, I have to start seeing if they all share the same ratio. Okay? So let's look at I'm going to call this one the new image, and this one the old image. So it's always new over old. So let's deal with the heights first. Let's deal with the heights. So I'm going to set 5 times the square root of 7 over 2 over square root of 7. Okay, I'm going to find this ratio first. Well, I could type it into a calculator, or I could think, here's a fraction up top divided by square root of 7. So I could write this as 5 times the square root of 7 over 2 divided by square root of 7, which is the same thing as multiplying by the reciprocal. And if I look, square roots of 7 cancel, and I'm left with 5 over 2. So this ratio is 5 over 2. Well, that has to equal all the other ratios. So let's deal with the slants here. And remember, I start with the new image first. So 5 root 3 divided by 2 root 3. Well, root 3's cancel, 5 over 2, so that checks out. And lastly, new image first, right? 5 root 5 over 2 root 5. Square root of 5's cancel. I'm left with 5 over 2. So there we go. They all check out, and my scale factor is 5 over 2. Okay? So they all, you have to check every single corresponding side to see if they have the same scale factor. That's the key, though. You can't just do one of them. You got to do them all. Our theorem for this section. Okay, one of these we already know. Well, if two similar solids have a scale factor of A to B. Okay, so I'm saying their scale factor, so if I pick two sides that correspond, their scale factor is A to B. Well, we talked about this a few sections ago. The surface area would have a ratio of what? Well, if I put the surface area of the first shape over the surface area of the second shape, it would be my scale factor squared. Remember doing that? It would be the scale factor squared. So it would be A squared to B squared. Okay? Well, volumes would have a ratio of what? I bet if you took your best guess, you would think it would be A cubed to B cubed. And if that's what you said, you are correct. So if I put the volume of the first shape over the volume of the second shape, and I picked two of their side lengths that corresponded, A over B, that scale factor cubed would be equal to the ratio of the volumes. So let's look at a quick example here. So let's say I had these two shapes, and they have a scale factor of 2/3, right? 2 and 3 here. Well, their surface area would be 2/3 squared, right? So their ratio would end up being 4/9, or 4 to 9 is what we would say. And the volume ratio would be 2/3 cubed. So in this case, 8 to 27. So we just apply those different ratios depending if it's surface area or volume if we know the scale factor. So let's try something here. I have two similar cones that have radii of 9 inches and 12 inches. What is the ratio of the volume of the smaller cone to the volume of the larger cone? So this is important. It wants the ratio small to large. Okay, so basically in the end I'm going to have the small over the large for the volumes, right? So if I think about it, here's my scale factor. These two correspond. I could draw a picture. I don't really need to. So I got one cone that has 9 inches. I got another bigger cone. They said they're similar. So if they're similar, I can say that they have a scale factor of 9 to 12 or 12 to 9, whatever you want to say. But we're saying small to large, so I want the small first and then the large on bottom. Well, to find the volume, I know that the ratio is basically the scale factor cubed, right? It's the scale factor cubed. So I just got to cube both numbers. So I got to take 9 cubed, which is 729. And then I got to take 12 cubed, which is 1728. And I really should simplify this. This sort of gets tricky. So let's use our calculator. I'm going to type in 729. I'm going to hit my ABC button to get a fraction over 1728. And I hit equals, and it simplifies it for me. 27 to 64 would be my ratio of the volumes. My ratio of the volumes there. Okay, so just use your calculator. Don't spend a bunch of time trying to simplify that on your own. And you could write it as a fraction. You could write it with a colon as well. It does not matter. Either way is fine. Last example. I have two softballs that are similar. If the radius of the large softball is 1.9 inches, find the radius of the smaller. Okay, this one's going to get a little trickier. So I know the radius of this guy is 1.9 inches, and I want to find the radius of the smaller one. Okay, so let's take a look here. If I thought about the scale factor of the ratio of these softballs, I could say that 1.9, it corresponds to the radius of the smaller softball, right? So we're just going to use R. We're going to solve for R here in this case. Well, I can set that equal to, I have their volumes, correct? So I know that this ratio is equal to these volumes here. But the volumes are equal to the scale factor cubed. That's the key. They're equal to the scale factor cubed. Right? That was what we talked about 2 slides ago. Right back here. Right? It's the scale factor cubed. So let's distribute that cubic power there. So 1.9 cubed gives me, distribute it there, 6.859 over R cubed equals 9.15 over 4.06. Okay, and I can take the cross product here. So I'm going to multiply 6.859 times 4.06, which gives me 27.84754. And then I have 9.15 times R cubed, right? The cross product here. Well, then we divide by 9.15. And that leaves us with 3.043. It goes on for a while. I'll round up right about there. Well, I know how to do it if I have like an R squared, right? If I had something like this, I just take the square root on both sides. And really, the square root, whether you know it or not, there's an imaginary 2 that sits out front because it's the square root, right? I'm reversing the squaring, right? So in this case, I'm going to take the cubic root, is what we call it. The cubic root. So I'm saying what number times itself 3 times will give me 3.043447. Let's think about one that we would know. I know that 3 cubed is 27. So if I took the cubic root of 27, I would get 3. Because 3 times 3 times 3 is 27. Well, to type that into a calculator, what I need to hit is, I need to hit the 3 button first to get the cubic. And then if you look, we have this button, like the caret button right here. And it has a little blue X with the root right there. Okay, so I need to hit the second button to get that. Hit this, so hit 3, then hit second, and then hit the caret button in order to get this. So it should show up as 3x root, and then we type in our 3.043447, and we hit enter, and that's going to leave us with 43447. R equaling 1.45 inches, right? Inches. So that would be the cubic root of that. So something new for you if you haven't dealt with those cubic roots yet, but that's how you would type it in the calculator. 3, and do the root that has the x in front of it. We do the 3 because we want the cubic root, and then type in your number. Okay, that's all I got. Good luck on your assignment.